Hi, my name is Charles Goodluck, and limnology is the topic of this video. Limnology, from the Greek origin lemne, meaning lake, and logos, meaning knowledge, is the study of inland waters. Limnology falls under the division of environmental science. Limnology includes biology, chemistry, geology, and physical states of waters. Inland waters can be called running, such as rivers, streams, springs. These flowing waters are lotic. Lentic or standing waters, such as ponds and lakes. Limnologists study naturally made and man-made bodies of water and can determine if the water is salty or fresh. These waters and the information about these waters are carefully examined by scientists called limnologists.
Hi, my name is Joel Smith. Limnology is important because without fresh inland water, life on Earth would pretty much be impossible. Understanding lotic and lentic water systems worldwide is imperative in a world of rising temperatures. With climate change occurring globally, it is paramount to understand potential impacts of drought and of saltwater mixing with coastal estuaries and freshwater systems as sea levels rise. And obviously the most important part to understand about limnology is fresh water for drinking, which everybody depends on, including plants and animals.
Today we'll introduce several limnology topics along with the sampling methods that go with the topics. These topics and methods include
aquatic invertebrates using microscopes.
Lakes, measuring light, temperature, and dissolved oxygen.
Bogs, using sweep nets and Van Dorns.
Streams, using a shark backpack.
Fish, using seine net.
Am I hungry?
Me too. What's your favorite type of food?
Definitely anchovies.
Gross! Wait, aren't anchovies a type of fish? There are tons of fish in this lake. What do you think they eat?
Cookies.
I was thinking burritos.
Huh. Maybe we should go ask Dr. Kickapoo.
Great idea. Let's go.
To the lab! 1, 2, 3. Time to find Dr. Kickapoo.
Oh, there she is.
Hello, students. What brings you to the lab today?
We have a very important question to ask you.
Do you know what fish like to eat?
Funny you should ask. I was just looking at some fish food under my microscope.
Whoa, they're so small you can't even see them?
Well, you can see them, but the microscope makes them appear much bigger. This is where we put the sample. It's called the stage.
Can we look?
Yes, of course. Just look through here like you're looking through a pair of binoculars. These are called the eyepieces.
Wait, I can't see anything.
Oh, silly me! I forgot to turn on the lights. The light switch is right here.
Aw, I still can't see anything.
You're doing it wrong. Let me try. Is it supposed to be this blurry?
Did you make sure to focus the lens? Well, to focus the lens, you turn these knobs right here, just like you're turning a doorknob.
Whoa, I can actually see now. What are these things?
They're called aquatic invertebrates. invertebrates don't have a spine like you or me or your pet cat or dog. Instead, they have an exoskeleton.
Exoskeleton? Are those like the skeletons we see on Halloween?
Well, not exactly. The skeletons you see on Halloween are made of bones, and bones are inside your body. Bones hold us together, but exoskeletons hold aquatic invertebrates together. They are like a hard, crunchy outer covering. Aquatic invertebrates are like the insects you see outside, except for one cool difference. They can live underwater. That's what aquatic means.
What's this one?
It's an odonata larva.
What's a larva?
Just like butterflies start as caterpillars, aquatic invertebrates look different when they are babies. The baby form is called a larva.
But what's an
An odonata is a fancy word for a dragonfly. Scientists like me like to use fancy words, so we give scientific names to all plants and animals.
Cool. Let's look at some more.
Yeah, this is just one type of aquatic invertebrate, but there are many different types that do many different things. This odonata eats other insects, but other invertebrates eat plants, and others eat dead plants and animals.
Oh, cool! Look at those legs!
Ah, that one's so cute.
Whoa, those are cool eyes! Thanks, Dr. Kickapoo. Now that we know what fish eat, we can finally eat. Then let's go fishing!
Yeah.
Alright students, see you later. I'm just about to have my own lunch.
Oh, hello. What are you doing here? Are you here to learn about streams and rivers? Well, let's dive in.
Rivers and streams are bodies of water that eventually flow into the ocean and connect lakes. Flow is how we describe water moving in one direction. For example, take this stream behind me. Its flow only moves in one direction and it flows that way. Radical!
The water from streams can come from many different places.
Stream water can come from the melted snow and ice on the tops of hills and mountains, or from rain that flows down hills.
Water can also come from the ground. The water that's in the ground is called groundwater, and it stays at one level called the water table. Groundwater stays between the rocks and the ground. Things still a bit murky? Let's ask the rock doc. Rock doc!
Take this cup of rocks, for example. When you pour the water in, the water fits between the rocks. Sometimes, if there's too much water, it can flow up above the ground. Whoa!
Hey, Carly, what are you thinking about?
All streams can't be the same though. What kind of streams are there?
What we call the beginning of the streams the headwaters. Eventually, the headwaters form together to make larger streams. As streams join together, they become wider, deeper, and faster flowing.
Because headwaters are so small, the trees growing next to it can't let very much light through, just like this channel. Not much can grow here. But as streams get wider, the trees can't cover all the water here. That lets more light through. And little plants called algae can grow in here and make sugar out of sunlight.
Really? That sounds awesome!
Yeah, and once algae are making food in the water, aquatic animals can live there too. And once streams get wider, aquatic animals change too.
Stream rock! Let's go check out some streams.
Rivers are made up of different parts. Right here, the river flows very fast and has lots of large rocks. This area is called a riffle. This area over here is very slow moving and has few rocks. It's called a pool. Rivers can even have waterfalls. Each of these parts of the river are different habitats.
A habitat is where an animal lives, just like your bedroom is where you live.
I love my habitat!
What is this? Limnologists studying a lake. Let's find out what they're doing. Hi there. What are you guys up to? Oh wait, I think you're missing something. That's better. Now what are you doing?
We're measuring the light, oxygen, and temperature of the lake.
But why are you doing that?
To answer that, we need to head to the kitchen.
You see, lakes are like sandwiches. They have layers.
Layers are based on the density of the water. The most dense layer is at the bottom, and the least dense layer is at the top. In the summer, the coldest, most dense layer is at the bottom. In the winter, the most dense layer is still at the bottom, but the coldest layer is on top. Why is that?
Ice floats. We call these layers stratification. The bottom layer is called the hypolimnion. Brr, the bottom layer is dark and cold. In most lakes, it's about 4 degrees Celsius all year round. The top layer is called the epilimnion. It's warmer, has more sunlight, and plants grow there.
We call the part of the lake where the light reaches the bottom the littoral zone. Plants like these use sunlight to make energy there.
The middle metalimnion layer is where the bottom hypolimnion and the top epilimnion layers meet. The temperature changes here. Now during the seasons, the layers mix. The bottom layer and the top layer become about the same temperature in the spring and the fall, and we get this effect called turnover, where they mix, and it looks kind of like this. Hey, I'm not eating this.
And now, back to the lake. So you see, we can learn a lot about a lake by measuring temperature, light, and oxygen.
To measure that, we use these instruments. This measures the oxygen level and temperature of the lake water.
And this is the light meter, which measures light at different depths in the lake.
Now what do you think will happen as the light meter is lowered? That's right, there will be less light the deeper that the meter goes.
At 1.5, the light level is 10.89. And at 2 meters, the light level is 7.82.
Recording data is important. We keep our field notebooks well organized and record the light measurement at each half meter.
Anybody thirsty?
Ew, what's in this water?
We bottled water from 2 different lakes. You're drinking water from a eutrophic lake.
They have lots of algae and plants in them due to a high level of nutrients. This causes the lake to be murky and have low oxygen levels, especially at the bottom.
Clearer lakes are called oligotrophic. They have fewer plants, more nutrients, and higher oxygen levels.
Actually, though, you should not drink water straight from any lake, no matter how clear. What limnologists study is important because they can teach us about how lakes become murky and eutrophic or clear and oligotrophic. Understanding lakes is important because they are sources of fresh water that we use every day. You can help keep lakes clean by picking up litter around lakes and especially watching out for chemicals like fertilizers added to yards that might wash into lakes and add extra nutrients.
Hey guys, you want to go fishing?
Hey Camden, yeah, that sounds awesome.
All right, let's go.
We are going to be fishing in Tenderfoot Lake.
Tenderfoot Lake is a great lake to fish in. It has plants and aquatic invertebrates, which you just learned about.
There are 3 different kinds of fish based on what they eat. Some fish eat plants, some eat aquatic invertebrates, and some fish eat other fish. This is why Tenderfoot Lake is such a good lake to fish in.
If there are no large fish in the lake to eat the smaller fish will take over and eat all the plants and aquatic invertebrates.
Let's take a quick sample of this lake. Since we're going fishing
For science,
we get to use a seine net instead of a hook and line.
This is a seine net, and we're going to show you how to use it.
So what we just did is we took this net and we made a big loop in the water, and now we're going to pull the net in, and all the fish that were in the water in the circle of the net are going to be caught.
Let's take a look at what we caught.
This is a pumpkin seed. They eat plants and other invertebrates.
And this is a perch. They eat plants and invertebrates, but sometimes they'll also eat other small fish.
These are just some of the fish that we caught in Tenderfoot Lake, but there's a lot more fish that are in this lake as well as many other lakes. Hopefully one day you get to go out and sample your own fish using this method as well.
Hello, mate. Welcome to the bog. So, what's a bog? A bog is a very wet habitat.
But what makes it different than other wet habitats?
A bog has a buildup of moss called sphagnum.
Guess what else is cool about sphagnum?
What?
It builds up on top of itself so that it starts to fill in the lake that makes the bog.
So we're standing on a lake?
Remember, it's always important to practice safety. Bog surfaces can be unpredictable, and you could fall through.
It's a very acidic environment, which makes it hard for most organisms, like fish, to live in it.
What does it mean to be acidic?
Think of it this way. Would you rather have a cup of acidic lemon juice or neutral water? Hey, check this out. There's this crazy plant over here.
Whoa, that's a pitcher plant. They can live to be 100 years old.
And still young.
Unlike most plants, they don't get their food from the ground. Instead, they hold a bunch of sweet liquid that attracts hungry insects. But instead of insects snacking on a plant, this plant snacks on the insects.
Why would any insect ever fall for that?
It's kinda like.
Oh my god. You guys. Free Oreos. Come here. Free Oreos. The best day ever.
I know, right?
What's happening?
So, speaking of insects, how do we know what else lives here?
We can sample the bog. Everybody grab your sweep nets.
I found something.
These dragonfly larvae love bogs.
What's in that deeper water? If fish don't live in it, then what do?
All right.
All right,
We're ready to go.
Wait! You're forgetting something very important. That's better.
We can use this Van Dorn device to catch organisms that are smaller than insects. Here's how it works.
Now we're gonna catch some microorganisms. Now we pull up the Van Dorn, and we have our water sample. Let's take them back to the lab.